Hello everyone, welcome back to my YouTube channel. In one of my previous video, I have shown you how you can import time-dependent quantity for your transit simulation. In today's video, I am going to show you how you can import spatially varying data that could be used for transit as well as for steady-state simulation. We can import in two ways using CSV file or text file. Here is the standard format for CSV file. The first row is fixed, you have to write name within the bracket. The second row you can choose whatever name you like. The third row is also fixed. The fourth row also kind of fixed. First three quantity indicate x, y, z that you have to write as it is because it is your spatially varying data. And the fourth column you can choose whatever name you like. For example, I am using this geometry where I want to apply velocity on this line. So my x would be 0, all these are 0. Y is varying from 0 to 10 millimeter. I have converted into meter because data should be in SI unit. The Z is 0 because my plane exactly at the origin. Here is my velocity which is starting at 0. At y is equal to 0 and it is increasing slowly up to 0.6 and then decreasing towards the end. So let's import this CSV file. We are in Fluent. Let's import our CSV file. For that, go to File, Read and Profile. Here you can import csv.prof or .ttab. We are importing .csv file. I am just locating my file and I have selected my file. When you select your file, you would see this message in the console. Reading CSV file 11 inlet point. It is just indicating that it has read your CSV file. Now let's go to the boundary condition. I'm not going into the setup. I have given the name to inlet. Go to the inlet and here are velocity. When you go into the drop down, you should be able to see this one. So x coordinate, y coordinate, z coordinate, then inlet y velocity. So we have to select y velocity. We can select apply and close. You don't need to change anything and we can directly run our simulation and can check. So I will run simulation, initialize and calculate. Simulation is finished. Let's check our result. Contour, we want to check velocity, velocity magnitude and select all of these and save display. Close. Here you can see our velocity profile. At 0 we had 0, then it was increasing slowly and here we had somewhere 6. So you can see we have correctly implemented our velocity profile. Now let's check from text file. In text file the format is little bit different, everything else is same. So first you need double parentheses, then you have to give name, whatever name you like, then you are saying you are going to give how many points. So I am going to give 10 points. Then separately you have to define your x coordinate, your y coordinate, your z coordinate and your velocity. One thing, when some data point is not available, for example between 7 and 8 millimeter, Fluent will linearly interpolate data between these 2 points. And the extension of your text file should be .prof. Just right click and change your extension. Now let's import our text file. Go to File, Read, Profile. I am locating my profile. It will be .prof. It has read my profile which has 10 data points. And you can see inlet underscore text, that is the name of file that you could see in text file. Anyway, let's go to the boundary condition inlet and select our profile. So it is inlet underscore text velocity. We can select this one, apply and close. Again we can run our simulation, number of iteration 10, right click and solve. Our simulation has converged. Let's check the result. Contour, velocity, magnitude, all of them save display. And you can see it is varying slowly from 0 to maximum. On the other side, it reaches to maximum pretty fast. That's how you can import your spatially varying data. It could be used for both steady state as well as for transient simulation. I hope you found this tutorial helpful. Thank you for watching and see you in the next video.